Okay, we're in section 4 of the notes. It's a section, it's the kind of introduction to polynomial function that really overlaps with what you've done in Math 100. The polynomial function that you really concentrated in Math 100 was the parabola, all right? I will move to the whiteboard, we will discuss through this, but for the most part, it's a review of what you've done in Math 100, right? The problems might appear to be slightly different, but they're essentially the same problems you see in Math 100. So again, it's like the introduction to polynomial functions. Again, I'll talk about this a little bit later. I also want to remind you, there's little embedded videos over here. You're more than welcome to watch those videos if they're helpful. Also, if you want to consider, maybe go to the internet and search Wikipedia for polynomial functions, and you could see they probably have a lot of pages written out for polynomials, right? An important class of function, and you want to pay attention to that. Again, if you're thinking of moving forward in a STEM-related career. If not, though, whatever you're involved in, you'd want to pay attention to what you're involved in. All right. So I'm going to say parabolas, typically, what points did you talk about in Math 100? X-intercepts, Y-intercepts, the vertex, an axis of symmetry, and the general shape of the curve. All right. We'll go through the example at the board. Again, for students that want to watch little embedded videos, they're there for you if you want to watch them. All right. We also talked about a formula that was derived in Math 100. I'll do it again at the whiteboard if you want. You can derive it too. All right. Then we'll go through example questions. And after we do that, hopefully you say, yeah, this looks familiar to me. I'm ready to try on my own. We want you to try. But here's the deal. Listen to lecture, try to follow the examples that we present to you, and then you try on your own clock too, not during class time, outside class time. You need to spend a lot of time outside the classroom studying, all right? Particularly if you want to be competitive, you're going to have to study a lot outside the classroom. So there's some supplemental problems over there. And of course, I do present some Sage code for you. Yeah, if you want to, you can look at the Sage code. All right, we're not going to test you on it though. All right, I'm going to switch to the whiteboard now. Give me 1 second to do so. All right, a little time to warm up that time, right? So you're looking at the notes, and what I'm going to do is just talk through it. All right, so let's start. And let's start with polynomial functions, start right off the bat. And, not that I want to read the notes to you. Certainly, I'm not going to read a large part of the notes to you, but, you should understand that we're talking about polynomial functions. Now, again, I want to emphasize over here, it says that n is in the positive integers. All right, that's a Blackboard Z. So what is a positive integer? Like, what are we talking about? Like 1, 2, 3, 4, 5, blah, 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 blah. All right. So what they say, we have a form like this over here of a polynomial. And what's it going to be? Well, an is some coefficient for the, I'm going to say the nth term. There's actually n plus 1 terms in the problem, by the way, because it starts at 0. So it's a coefficient of the variable x raised to the power n. And then the next coefficient is a sub n minus 1 times x to the n minus 1. That's the coefficient, n minus 1. The power is n minus 1. All right. And again, n is a positive integer. All right. All right. So we have it. We have what a polynomial is. Now the question comes is, what polynomials are you going to start us with? Well, they could start you with lines. We've done that many times before. What they're going to start off with, though, is what's a quadratic, exactly the way you were given it in Math 100. All right, so we're going to be covering initially the quadratics. But then we're going to move to higher degree polynomials. And they are definitely more difficult to graph. But we'll get there. I will say this, though. We tend to give problems that aren't difficult. We give problems to illustrate what we're talking about. All right. So I want to look at this picture over here. And if someone says, if you're looking at this picture over here, I think you probably should know it's a parabola looking at it. Right. This goes on forever. I'm just tracing over it with a highlighter at this point. That's a parabola. It goes on forever upward. If someone said, if that's a parabola and they said, what's the domain of it? I could write, oh, the domain is all real numbers. A parabola has no divisions, no even root takings. What's the range of this particular parabola? I would say it looks like it's starting at -4 and going off to infinity. If someone said this parabola, what are the x-intercepts? I'm looking at the picture. I would probably say the x-intercepts, looking at the picture, -3, comma 0, and the other one appears to be 1, comma 0, right? If someone said, what's the y-intercept? Again, I'm looking at the picture. I would say the y-intercept is -3. Whoops, made a mistake already. The y-intercept when x is 0. Sorry about that. And the y is going to be the value -3. If someone said, what's the vertex? Again, I'm looking at a picture. And what am I noticing in that vertex? Well, looking at it, I'm noticing it's -1, comma -4. And what else do I notice? I notice in the picture there's an axis of symmetry, and that's a vertical line, and that line is x equals -1. These are things that you did in Math 100. What I mean by that, you did domain of the parabola, you did range of the parabola, you did x-intercepts if they were easy, you did y-intercept, it was always easy at the 100 level, you certainly did the vertex, and you certainly did the axis symmetry, and you also graphed it. It's a given. You've done that Math 100. What I want to do is I want to just emphasize, if you were doing that, but not given the picture, how would you have done that? So let's take the example. And the example that I'm going to take is this, the example they've given me. All right? I'm going to tell you what they've done in Math 100. All right. So let's write this down. We're going to graph y equals x squared plus 2x minus 3. Well, Math 100, probably your teacher says, if it's factorable, please factor it. So let me write that down. Let's see if it's factorable. By the way, that's a big if. If it's not factorable using finger numbers, we're not going to factor it. So I'm going to say 3, not now anyway. We're going back to Math 100. 3 and 1 is about the only choice I could come up with. So plus 3 minus 1. Let's see if that works. You get x squared. 3 minus 1 is plus 2. Yeah, it works beautifully. Then from this form over here, they would have said, could you write down the y-intercept? And you can. How do you do that? Set x to be 0. And if you do that, you would get -3. Then they'd say, can you get the x-intercept? And they would say, to get an x-intercept, set the y equal to 0. And that's pretty easy. What do you get? X minus 1, x plus 3. Well, when would that product become 0? When x is 1, y would be 0. And the other place would be -3, comma 0. They would also say, get the vertex. Now in Math 100, and I'll derive the formula later, they basically give you the formula. I hope they did derive it for you in Math 100 as well, but it's going to be, you'd have to identify, let's see, you'd have to identify the A. I want to point out what we're looking at. We're looking at this. Let's see, A is 1. You would identify the B. The B is 2. And not that it's important, but you probably should identify the C as well. It's -3. All right. So the vertex, let's write this down now, is going to occur when x equals, and we'll derive the formula later, minus b over twice a. Let's write that down. So x, we're deriving the vertex, x equals, well, what's the opposite of b? It's -2. And what's twice a is 2. So it would occur at -1. That's where x is -1. So what do you do now? Well, you write the point down. -1, comma. I hope you're not struggling too much, but you would take the -1 and plug it in up here. What would you get? 1, -2, -3. Well, 1 minus 2 is -1. -1 minus 3 is -4. Then your teachers would have said, you could also write down the axis symmetry. And the axis symmetry would be x equals -1. It goes through the vertex. Then they would have asked you to graph it. And everything should fall into place. Let's put this down now. Now, what do I put down? The y-intercept. That's done. The x-intercept. That's done. The other x-intercept. And I don't think your teacher was too much of a stickler on it, making perfect detail. What else would you put down? Probably the vertex. Where's that going to be? Right here. What else would they put down? The axis symmetry. I'm going to use a different color, and that's x equals -1. Goes through the vertex like this. And most teachers at Math 100 levels, they put a dashed line in for that. And then I'm going to draw my parabola. It's symmetric about that line. Okay, let's go back. Are we getting the same picture? Of course we are. What picture's better? The one the machine does. All right. I'm going to go to the next page. We're done with this one. This is a little bit of review of what you've done in Math 100. Let's go to the next page. And let's talk about this formula and how they got it. All right. So what I want to do is I want to write down how they got the formula. Now, you may not be interested in it, and that's fine. You're not interested. That's fine. I would say this is a good idea to have an interest in something. So I'm going to write general form down like this. And what I'm going to claim is this, that the vertex is dead center between the x-intercepts. Let me go to the other page and point out what I mean by that. If you looked at the vertex, it's the dead center between the x-intercepts. Now that's true, whether they're nice or not nice. The vertex is always going to be in the center. And why is that? There's a line of symmetry. For example, you look at the distance here. The distance here is 2. The distance there is 2. That's that line of symmetry, which means the vertex is the dead center. It's got to be on that line. So what is that telling me? That's telling me if I knew the x-intercepts, I could figure out the center of it. And we're going to derive that formula now. Now, how do I figure out the x-intercepts? All you have to do is set f of x equal to 0. And I want to point out f of x is just like saying y. So if I set y equal to 0, I'm actually getting the x-intercepts. And let's write those down. How would I do that? 0 equals ax squared plus bx plus c. Well, I don't know what a, b, and c are, but I do know the quadratic formula, and I hope you know that too. Twice a, and what do you get on top? Let's see, minus b plus or minus, a nightmare, isn't it? B squared minus 4ac. So I have two x-intercepts, and I'll write them down for you. One is minus b minus b squared minus 4ac. This is really terrible, isn't it? Over twice a, comma, the y would be 0. What's the other x-intercept? Minus b plus this. It's a lot of work. Now, by the way, someone says very abstract. Why do you put all that abstract work down there for me? We're trying to derive a formula. And what did we say? We said that that axis symmetry was dead center. So all I got to do is figure out what the dead center is. How do you do that? It's a midpoint. That's all it is. So if you did the midpoint, I hope you realize the midpoint. Well, the y coordinate, yeah, those get 0 plus 0, 0, 0 divided by 2 is 0. Let's add those two numbers together, though. And I want to point out what I'm adding together. I'm adding this and adding this. You have to add them together and then divide by 2. Well, if you added those together, what would you get? Minus 2b, whoops, made a mistake. You would get minus 2b over 2a. The radicals would disappear. And if you divide by 2, it's like multiplying by a half. And what would that give you? Minus b over 2a. And that's where that comes from. Whoops, I did it again. Sorry about that. That's the midpoint. So what do I know? The midpoint has the axis symmetry. So the AOS is x equals minus b over 2a. And where does the vertex lie? On the axis symmetry. Minus b over twice a. You got to figure out the y now. And by the way, I'm not saying it's not 0. It could be. How do you do that? All you have to do is plug it back in up here. So I'm going to just simply put that down as an abstraction. And I'll write that down for you. So you'd plug in F, whoops, let's go back to black. F of minus B over twice A. All right, let me go back to the notes. And I'm going to point out what we're talking about over here. And I'm going to get my highlighter out. And we're talking about this over here. And this is what you did in Math 100. All right. So I want to claim that this is really not a bad thing. And I'll tell you the number one reason why. Sometimes the vertex can be rather nasty. Generally speaking, it's not though. But that's a really nice formula to know for the vertex. It also gives me the axis symmetry, which is x equals minus b over twice a. All right. I want to point out they're also saying something about over here that our parabolas of math are of one of two types. They either opened up like this, or they open down like this. And you should start to realize if that's the case, that this would be a minimal point and that would be a maximal point. It's a good idea to understand that because some of the questions will relate to that. And we'll go to the questions next. All right, or I should say the examples to hammer across these points to you. Thank you.